Okay, since I asked you to describe where this puppy shows up, and I heard like the loud murmuring going on, this is what I heard a lot. I heard, oh, well, the puppy shows up in between like 2 and like 11. On which axis are you talking about when you say 2 and 11? The x-axis, cool. And then I heard people say, oh, and also it's between like 1 and 16 or 15.5. On which axis? The y. That's awesome. That's what I need us to be able to do today. I'm going to clean it up. I'm going to make it math after this, but you just described the domain and range of this puppy. What? That's math. Here's my next question for you, though. Here's Elastigirl. With your same partner, can you describe where Elastigirl is on this map? So here are some of the things that I heard when I asked you to do that were great. I heard somebody say, she's all over the place. You're not wrong. I also heard that she goes from like -10 right here. And then what happens this direction as she keeps going?
15.
What happens? This is Elastigirl. What can her leg do? It stretches all forever and ever and ever and ever and ever. What number does it go to if it goes on forever and ever? Infinity. Elastigirl is going to start at -10 on the x-axis and go to what? Infinity. Did anyone describe how she looks from like up and down?
No.
Where is she at the top? -2 and to negative infinity, TBH, because these are the negative numbers. So as her arm stretches down, she's going towards negative infinity. My friends, you just described the domain and range of Elastigirl, and you didn't even know it. Because today, all we're going to be doing is taking these kind of continuous functions and describing where they are on the graph. Yeah? Okay, you can go back and find your seats now. We defined some of these words last class. But we're going to redefine them just in case we forgot, / we slept since then, / if you didn't glue your notes into your spiral, you probably lost them. Totally cool. When we're talking about our domain, remember that we are still talking about the set of all input values. And our input values are our x's. Last time when we watched the video, we had the chickens and the chicken nuggets. Those were our inputs, the chicken, the fish, the steak. Those were the inputs because they went in the function machine. The range is the set of outputs. Which is our y values. Last time we also talked about discrete functions. If you remember, discrete functions are disconnected. They're disconnected. There maybe are scatter plots. Those are disconnected data. Or they are measuring or counting things, aka you cannot have fractions. If you're looking at the object that you're studying and you cannot take a fraction of it, like you can't take a fraction of a suitcase or a fraction of a person, okay, that would make it discrete data. But today, we're going to be dealing with the other type of data, which is our continuous data, which is connected. So discrete is disconnected, continuous is connected. So it might be a line. That's some connected data. And since these are all connected, you can have fractions. Any number works in a continuous data, not just whole numbers. So yes, fractions for continuous. Fractions. Yes, no fractions. Now, continuous functions, we kind of talked about this already. We're going to repeat this information. Continuous means connected. Which is nice that continuous starts connected, like discrete was disconnected. When we're talking about connected graphs, we're talking about maybe curves or straight lines, or we're talking about things that we can measure. If we're just given a table and told what its labels are, if we are told its labels, we're looking for inputs that you can measure, which means that we can have fractions. Yes, fractions. Some classic examples of things that are continuous include time, because time I can measure like half a second. I can measure 30 seconds of a minute. I can measure half an hour. So all of those things give me parts of wholes like seconds, hours, days, weeks, on and on. We could get months, years, decades. All of those things are time. Time is always continuous. Another classic example of things that are continuous, distance. Distance is continuous because when I'm measuring inches, I just don't go from 1 inch to another. I could have 1.5 inches. I could have 1 inch and 3/16. Those fractions allow me to know that distance is continuous. So maybe we have inches, maybe we have centimeters, meters, feet, yards, miles, kilometers. Whatever you can think of as a unit of distance, all of those distance units create continuous functions. Now these two visuals here left on the front of this packet is what I think is probably the most useful visual of what domain and range is. You have Dr. XY here again. We had this last time on our notes, and Dr. XY helps me remember that domain is my x's and range is my y's. But just like you were telling me with the puppy earlier, if you can pretend right, like this is the puppy, this like graph right here, okay? Pretend that's the puppy. And you described to me where the puppy showed up from left to right. You gave me this information. And without knowing it, you actually told me in words what the domain is. You also told me in words what the range is. So you already get the idea and the concept of domain and range. I'm just going to show you how to do this in a mathematical context with a math sentence as opposed to just like out loud in an English sentence. But you got it already. You got to tell me where that puppy shows up. You got to tell me where this graph shows up from the left to the right and from the bottom to the top. That's all we're doing today. It's just going to look a little complicated because the notation that we use is a little weird. Okay, meet me on the other page. That's all we're going to do here on the front. When we are describing these continuous functions, just like you told me for the puppy, you are going to describe these domain and ranges as inequalities. As an inequality. Because you told me that the puppy showed up between 2 and 11, we can use an inequality to say that in math. Here's the rule for domain. You're going to tell me what the left number is, which is the smallest number on the left side of the graph. You're going to give me either less than or equal to, an X in the middle, less than or equal to, next to the X, and then the right number. That math sentence right there, which looks bizarre right now until you see it in action, is going to tell me the domain of this continuous function. I bet you're thinking like, man, how am I going to remember that? Oh, wouldn't you know it? We have this image here called Dolor the Robot. It's spelled super funky on purpose because it's going to help you remember that the domain describes the graph from the left to the right, which is exactly why we have a left number and a right number here in my pattern. So if that's Dolor for domain, how do you think I'm going to write the range? What do you think the B and the T stand for? Bottom and top. We have left and right, so we're also going to have bottom with a less than or equal to. In the middle is a Y because I'm doing the range. Less than or equal to, and then my top number. Okay. Really, what's going to change from question to question is your left, right, bottom, top. The rest of it is practically going to be the same every time. You just have to pick the symbols and the numbers. And you've already done that with the puppy. You just didn't do it in a math sentence. So it's going to be easy to translate your English sentence in your head to a math sentence. Now, this is really confusing until it makes sense. It's one of those things that just looks like, what is happening until you get it, and then you're like, oh, this makes sense. Okay, so the first two examples, I want you to just watch. I don't want you to write down with me, so I want you to put your pencils down. I just want you to watch me do this so that you know exactly what's happening and where I'm getting my numbers from. Okay, if I'm finding the domain and range of these functions, first of all, I wrote down Dr. XY so that I remember that domain is the x's and range is the y's. Cool. So I follow this thought process. For domain, I look at the left of the graph. This is the graph I'm looking at. Is there anything over here? Is there any blue graph over here? No. The very left of the graph appears right here. What number, what x value is that? -2. That's my left number. That's a closed circle. Do y'all remember when we did inequalities? With a closed circle, did it have the line underneath the symbol? Yeah, so we're going to use less than or equal to. An x always goes in the middle for domain. And then I look on the right. What's the right number? 3. That's the furthest right that this graph goes. It's also closed. And voila, I've written the domain for this function. I'm telling you in math sentence that this function shows up between -2 and 3. -2 and 3. That shows up, right? Okay, let me finish the range and then I'll take some questions. If I'm doing the range, I'm going to look at the bottom of the graph. What y value is that? -1, and it's closed. Then I look at the top. What's the top number? 2, and it's closed. I'm telling you in this math sentence that the graph shows up between -1 and 2 on the y-axis. -1 and 2 on the y-axis. This is exactly what you did with that puppy. You just didn't write it down like this. So all we have to do is take what you understand about putting things on a graph and put it into this format. I'm going to give you guys a few seconds to write this down because I know you're actively watching me do that. So take a second. So when I come to the second example, I'm going to take my pencil and I'm going to find the very left of the graph. This is as far left as the graph goes. What x value is right there? 2. So 2 is my left number. It's an open circle. With an open circle, did I use less than or equal to? Less than, the open symbol. And x always goes with domain, because that's what domain is. Thanks, Dr. XY. And then if I look on the right, this is as far right as it goes. What's that x value? 7 with an open circle. So I'm telling you that this graph shows up between 2 and 7 with open circles at the end on the x-axis. For the range, I look at the very bottom of the graph. Is this the bottom of the graph? Does it go any lower than that? No. So that number is 1. With an open circle. And then if I check out the top, what number is there? 6 with an open circle. That's it. That's describing the graph. I'm telling you exactly where it shows up. Between 2 and 7 on the x-axis, between 1 and 6 on the y-axis. Go ahead and take a second and write this one down. Thank you for listening. Okay, if we would please, I want for you to try this one on your own. I'm tossing you in here. I know it may not be clear yet, but I want you to try. Your partner just explained to you how to do this. Okay, there's a trick on this one, and so if we fall for the trick, that's okay. I'll clear it up in a second. Take some time, try this particular problem. Apologize if I'm cutting off your thinking, but I've seen some good stuff, and I've seen some things that I want to clear up, which is totally fine. We just learned this concept. When I'm talking about domain, I'm thinking left to right. Here's the left number. -4, and it's open. Here's the right number. And it's closed. How do we do on domain? Good. A couple things I saw that we need to clear up. If you have an open circle, you use the open symbol. If you have a closed circle, you use the closed symbol. Okay? Then here's the domain, or here's the range. I'm going to do this wrong, and I want to see if someone can fix it for me. This is a mistake I saw a lot, and totally get why you did this. Okay. Bottom. Top.
That's totally wrong.
What's wrong about it? This is wrong.
It's not 3.
It's not 3. It's 2. How come it's 2?
Wait, why is it 2?
How is it 2? 2 where?
Because it's 3. Because it's the bottom. I'm slow.
Yeah, the bottom of the graph isn't always the endpoint. The bottom of this graph is actually right here. That's the lowest it goes, so that's the bottom. This number is actually 2. And it's since I didn't see an open circle. This is closed because I didn't see an open circle. If you see the closed circle, that's how you know it's closed. If you don't see any open or closed, you assume that it's closed. Okay, let's do this next one together. We're looking for left, right, bottom, top. For the domain, which is left to right, here's the left of the graph. What number is that?
0.
0. And it's closed because it's just a line. I don't see an open circle. I mean, I see a giant open circle because it's a shape. But I don't see like a dot, right? An open dot. So I know that it's closed. Then if I look on the right side, least to greatest, that's why it's left to right, we have a 6 that's also closed. We have now described where this circle shows up on this graph. It shows up between 0 and 6. Now what about the range? 0 is on the bottom, closed circle, right? And then 6 again on the top. Yeah, because it's a nice little circle there. So we're saying that this circle shows up between 0 and 6 on my y-axis, which is exactly what you guys told me when we used the puppy. Okay? All of these questions are like the puppy because we can say where the left and right number is and where the bottom and top number is. That makes them like the puppy. We're going to get to problems that are more like Elastigirl here in a second. Are there any questions about puppy questions here? Okay, let's go to some Elastigirl questions, which is usually where like all the question marks start showing up. I totally get it. What happens when you have an Elastigirl question is that you have arrows or like no endpoints to your graph. Your graph is going to continue on in one or both directions like Elastigirl did. In that case, arrows or no endpoints mean that the graph goes on or continues all the way to either negative infinity or positive infinity. So either it's going to get so small that we reach negative infinity or so big that we reach positive infinity. That's a weird looking infinity sign. So this is going to happen a lot in this class. Because a lot of data you take in like scientific classes, maybe you have no end. You're going to be able to project for the future, predict the future in math class. What? Sorcery. Anyways, when you're doing domain and range, and if you have an endpoint on one side but an arrow on the other, or arrows on both sides, you have a special case here. For the domain, we follow the same process. What's on the left? 0. And it's closed. But what do you notice on the right? It goes on and on. If I was following this to the right, would it ever stop? No, it would literally keep going all the way up to the biggest number we can think of, which is infinity. Now here's the deal though. We just followed the process and we did this right. But in Algebra 1, you're not allowed to answer with infinities. That's an Algebra 2 concept, so we'll save that for then. So what we would do is we'd cross out the infinity and we'd say, I'm done. But unfortunately, answer choices aren't written that way. They're always written with the letter coming first. So how do we switch 0 less than or equal to x around so the x comes first? There you go, yeah. If you flip the letter and the number, you have to flip the symbol. So this is what you'd see as an answer choice. This is still technically correct, but we don't really write it with the letter coming first. You always want to have your letter first if it's a one-sided inequality. Just like we did when we did inequalities with the number line. We're saying that all of the x values are bigger than 0. Well, that makes sense because we start here and we never end. Everything's going to get bigger than 0. Let's follow the same thought process for range. Here's the bottom. It's 1, right? Oh, I'm covering it up. 1. So 1 is the beginning of my range, and it's closed. But if I go to the very top, is this ever going to stop going up? No, it's going to keep going up just like it went to the right. So we're going to say less than infinity. But then we run into the issue that we're not allowed to write down infinities until we get to Algebra 2. So we flip it around, and we have our range. We're saying all of the range, the entire graph, shows up above 1. That's true. That whole graph is above 1. That's true. Okay? It's one of our special cases when we only have what's called a one-sided inequality. Okay? Where there's endpoints on one side but none on the other. That's technically called a ray if you're in geometry. If you remember that. That's a ray. Now, if we get to questions that are like they're not numbered, the second example, we don't see endpoints. Like there is not a physical dot or physical open circle that's telling me this is stopping. It's as if there are arrows saying that this extends. If we had a touch screen on this, we could zoom out. You would notice that the line keeps going for forever. When we follow the thought process that we've been using for domain and range, here's what we would do. I start on the left. Can I ever reach the left number here?
No.
What is the left number on this side of the graph? Negative infinity. I never can reach the end because it's got an arrow there. It's going to keep going for forever. What about the right side? Does it ever stop on the right? No, so I'm also going to put infinities. And I bet you're thinking, Miss Quigley, you just told me we could not have infinities in our answer. You're right. We don't. When we get double infinities like this, you're going to use the phrase all real numbers. Because there's not a single place that this domain doesn't make sense. All of the numbers make sense in this domain. There's nowhere it stops. All numbers work. But that's a lot of words to write down. ARN is fine, but there's actually a mathematical symbol for the phrase all real numbers because we're so lazy we made a symbol for it. The way you make the symbol, watch up on the board. You make 2 lines and you pretend it's an R. That right there is the symbol mathematically that represents the phrase all real numbers. You may write out all real numbers, you can write ARN, or you can make the fun and funky R. I'll accept all 3 as your answers. On your START test and on tests we'll write out the phrase all real numbers. You don't have to memorize that symbol. I'm just going to use it because I'm lazy. You're allowed to use it too. Let's follow the same thought process, bottom to top, for range. Can I find the bottom of this graph? No, it's like Elastigirl. It's going to keep going for forever. So I'm going to put negative infinity, less than y. Can I ever reach the top of this graph? No, it's like Elastigirl on that side too. It's going to keep going. So what was the phrase I use when I get double infinities? All real numbers. Or, if you're lazy like me, the fun and funky R. Again, to make the R, in case you're like, how do we do that? 2 lines, make it an R. That's the mathematical symbol for all real numbers. Yeah, so this happens sometimes. You'll get Elastigirl questions that extend one direction or the other, and that's okay. That's going to happen every once in a while. Can you guys try number, it's not numbered, but the 4th one, so it's this one right here. I want you to try this one for me. Okay, because it's our one last example of a special case that we didn't talk about. I want to see if we can grab it. Okay, I don't want to, I'm going to cut off your thinking here. What's up? Yeah, so here's our domain and our range. If we start using the same process for domain, I look on the left. Can I ever find the left number? No, it's an arrow, air quotes, arrow. It's going to keep going like Elastigirl, so it starts at negative infinity. But it ends at 3 with an open circle. Now I can't use the infinity part, so I just box this one. Boom, x less than 3. That's my whole domain. For the range, can I ever find the bottom? No, it's like Elastigirl again. It's going to keep going and going and going. So it starts at negative infinity with a y, but where does it stop at the top? Ooh, a decimal. We're going to approximate this to approximately 2.5, which is a bad approximation, but like you get it. Now we can't use the infinity part, so we just use the y.
That's a half though, 2.5.
Yeah, it's probably more around 2.8, but like 2.5 is fine. If it makes you feel better, I'll do the approximate symbol in here, so it's approximately 2.5. Okay, we've got 2 more examples to hang on for until I let us roll to something else. These last 2 examples are a little difficult only because they didn't physically show us what's happening on these graphs, right? We were doing domain and range really well when we could see it, but we're just given an equation. Here's the nice thing. you have an ability to graph these functions either on your calculator or with this program called Desmos. Let me show you Desmos really fast. It's domain and range. Yes, we just checked it on Desmos, and here's the graph. Here's 2, and here's my not quite vertical line. Ooh, that's real bad. Pretend that's vertical. Eek. Oh, I can't even look at that. It's really bad. Okay, let me try again. That's better. That's the spirit. All right. The domain is the x values. It's the left and the right. Is there any left over here?
No.
Is there any right?
No.
It's only 1 point, right?
Yeah.
What point is it?
2.
Okay.
We just do 3.
Yeah. If you got one number in your domain or one number in your range, you just put it as the one number. Sometimes people will write it as this, but that's not technically correct. Technically, you're supposed to put it in the squiggles and just say that that's the only thing in the domain. But x equals 2 still tells me that the domain is only 2. Now, what about the range? Can I find the bottom?
No.
Can I find the top?
No.
No, so we have that negative infinity and positive infinity thing. So what do we say for this? The R thing. What does the R thing stand for? All real numbers. Good, yeah. If we can't find the bottom or the top because it keeps going forever in those directions, we say all real numbers. Let me show you the equation y equals 5. X equals 2 is a vertical line. So y equals 5. So shout out to Desmos for helping us out. We know that this is 1, 2, 3, 4, 5. Is that 5? Can I count right? 1, 2, 3, 4. Yes. That's 5. Here's our our horizontal line at 5. So we find its domain and its range. Can I find the left number?
No.
Can I find the right number? So what do we write instead of the double infinities? What's the R stand for? All real numbers. Still got to call it all real numbers, but it is the fun and funky R. Now what about the range?
It's 5.
Yeah, the only y value I've used on here, since it's a flat line, is the number 5. Again, sometimes you'll see it just as y is 5 instead of an inequality, since it's only one number instead of an inequality. But that's not really correct. This is the more correct way to write this. So Elastigirl questions are a little bit harder than puppy questions, but it's okay. We're going to spend the majority of the day working on puppy questions, and we'll come back to Elastigirl questions next time. Go ahead and glue these notes into your spiral when you get a chance, and log into your Chromebook. I've got another activity for us to do today.